It's really incredible how much progress we're seeing with these large language models. They're not just, chatting anymore. They're
Yeah.
able to solve these complex problems.
Right.
And one of the things that's really pushing the boundaries, I think, is this idea of chain of thought prompting,
Got to.
or CUT-T for short.
Yeah.
And could you just give us a quick overview of what that is?
Yeah, so essentially CUT-T prompting is we're giving the model a few examples of how to reason step by step,
Right.
and then it learns to tackle new problems in the same way.
So it's like we're giving it a roadmap.
Exactly.
Yeah.
Yeah. And what's really interesting is they can pick up on this pattern and apply it to problems they haven't seen before.
That's so cool.
Yeah.
So today we're diving into this new research paper that really takes us inside this COT process
Right.
and tries to explore how these powerful LLMs learn.
Yeah, this paper focuses on two specific ways that transformers, the architecture behind LLM,
Okay.
can learn chain of thought prompting, stepwise and coherent.
Okay, so break this down for me. What's the difference between those two?
So imagine stepwise COT like a relay race. Each runner, or each step in the reasoning process,
Right.
is isolated,
Okay.
only using the information passed from the runner before it.
Okay.
With coherent COT, it's more like a team huddle.
Okay.
Each member has access to all the information that's been gathered so far. Each step integrates all of the previous reasoning.
So it's like it's constantly checking in with the bigger picture.
Exactly.
Okay, that makes sense. So does this actually make a difference in how well the model performs?
That's what the researchers wanted to find out.
Hmm.
And their findings showed that a coherent COT actually leads to more accurate results. And the reason for this is pretty interesting.
Okay.
When the model takes all the previous steps into account, it can actually spot potential errors that were made earlier in the chain and self-correct.
Wait, so it can backtrack and fix its own mistakes?
Exactly.
Huh, I wouldn't think that would make it more reliable.
You might think that sticking to a strict step-by-step approach would be more reliable.
Right.
But the researchers found that this holistic approach actually makes the model more robust and adaptable. It's like if you're trying to solve a complex puzzle, it's not enough to just focus on the individual pieces you need to be able to step back and see how they all fit together.
Yeah. Okay, so if coherent COT is so effective, does it matter where errors happen in the chain of reasoning?
That's a great question.
Would a mistake early on be more damaging than a mistake at the end?
Yeah, so the researchers actually investigated this
Oh,
by
good.
introducing deliberate errors or noise into different stages of the COT process.
Okay.
What they discovered is that the model is much more sensitive to errors in the intermediate reasoning steps
Oh.
compared to errors in the final answer.
So like a misstep early on can really throw things off, even if it seems like it gets back on track later.
Exactly.
Kind of like building a house on a shaky foundation.
Yes. Exactly. A small error early in the reasoning chain can have this cascading effect, potentially leading to a completely wrong conclusion,
Oh, wow.
even if the final step seems logical based on the information that it was given.
So that makes me wonder if these models are so sensitive to the quality of the reasoning that they're trained on.
Right.
What can we do to help them learn more effectively
Yeah.
and avoid these critical errors, especially in the middle of that reasoning process?
Yeah, so the researchers tackled this question, and their proposed solution is something they call error-aware demonstration.
Okay.
Instead of only training the LLM on perfectly executed examples of COT,
Right.
they introduce examples where mistakes are deliberately included.
So they're kind of giving it a crash course in how to spot and recover from common errors.
Exactly.
Okay, so how does that actually work?
Essentially, they present the model with a problem, and then they show it an incorrect reasoning path, clearly labeling it as wrong.
Okay.
But crucially, they also provide a detailed explanation of why that reasoning is flawed.
Highlighting the specific errors and the logic behind the correct approach.
So it's not just about showing it the wrong answers, it's about giving it a structured way to understand why those answers are wrong.
Exactly.
Okay, that makes sense.
Yeah, and it sounds like it would require a lot of thought to create these error-aware examples.
Yeah.
It does. But the researchers believe it's a critical step in training more robust and reliable LLMs,
Okay.
especially as we move toward these more complex and nuanced tasks. And they actually put this method to the test using real LLMs
Okay.
in challenging benchmarks like data understanding and math problems.
Cool.
What they found is that adding these error-aware examples consistently boosted the model's performance.
Wow. So just by incorporating those imperfect examples,
Yeah,
we're kind of teaching it to think critically and learn from its mistakes.
exactly.
It makes you wonder if we as humans could benefit from adopting a similar approach to learning.
That's a thought-provoking question.
It suggests that maybe our traditional methods of education, which often focus on memorization and rote learning, could be missing a crucial element.
Yeah.
What if instead of striving for perfection, we embraced the idea of learning from our errors?
That's a great point. Maybe by analyzing our own mistakes and understanding the reasoning behind them, we can develop like a deeper and more nuanced understanding of the subject matter.
Right.
I'm curious to know more about how the researchers actually implemented this error-aware training.
Okay.
What kind of specific examples did they use, and did they test this method with different types of LLMs?
They did, and the results are quite interesting.
Okay.
But before we dive into those details, maybe let's take a quick break, and then when we come back, we can explore some specific examples of how this error-aware training works in practice and discuss the broader implications of this research.
Sounds good. Okay.
Let's take a break.
So to answer your question about the types of LLMs they use
Okay.
and the tasks they use to test.
They actually worked with several different models, including GPT 3.5 Turbo, GPT 4 Mini Gemini Pro, and DeepSeek 67B.
Wow, that's quite a lineup.
Yeah,
So they really wanted to see if this approach worked across different model architectures.
exactly.
Okay. So what were some of the tasks that they used?
So one example is date understanding,
Okay.
where the model might need to figure out the date 10 days before Christmas in a particular year.
Right.
Another task involved tracking shuffled objects, like keeping tabs on which ball is held by which person after a series of swaps.
Okay. Those are great examples of tasks that really require you to think through the steps carefully.
Yeah.
It's not something you can just solve in one go.
Right.
So how did they actually incorporate the errors into these examples?
So they followed a specific format.
Oh,
They present the problem.
okay.
Then they offer a potential line of reasoning that is incorrect,
Okay.
clearly marking it as wrong.
Okay.
Then crucially, they explain exactly why that reasoning is flawed,
Okay.
pointing out the missteps or the logical errors.
So it's like, here's a wrong way to think about this problem,
Yeah.
and here's why it's wrong.
Right.
Okay. Did they just throw in any kind of errors, or were there specific types of errors?
So the errors were designed to be relevant to the task at hand.
Okay.
For example, in the date understanding problem, an error might involve miscalculating the number of days in a month or forgetting to account for leap years.
Okay.
In the object tracking task, an error could be mixing up the order of the swaps or misidentifying who ends up with which object.
That makes sense. You want the errors to reflect the kinds of mistakes that the model is likely to make.
Exactly.
Okay, so I'm curious about the results. Did these error-aware examples actually improve the model's performance?
Yes, they did.
Okay.
In most cases, adding these handcrafted incorrect reasoning paths to the Cody demonstrations led to a significant improvement in the model's accuracy.
Okay.
Sometimes the improvement was over 5%, which is pretty substantial.
Yeah, that's huge.
Yeah.
Especially considering how complex these reasoning tasks are.
It-
Okay, so it seems like incorporating these imperfect examples is really key to helping these models learn more effectively.
Right, and they didn't stop there.
Yeah.
They also wanted to make sure it was the explanation of the errors that was driving the improvement, not simply the presence of wrong answers.
Yeah, that's a good point. Just showing the model a bunch of incorrect answers without explaining why they're wrong wouldn't necessarily be helpful.
Right.
So how did they test that?
So they ran what's called an ablation study,
Okay.
where they remove one component at a time to see what effect it has.
Okay.
In this case, they tested the method with only the incorrect reasoning path,
Okay.
but without the explanation of why it was wrong.
So they're kind of giving them the wrong turns, but not the map to get back on course?
Exactly. And the results were pretty clear.
Okay.
In most cases, the performance dropped when they removed the error explanations.
Interesting.
Yeah. This suggests that just presenting incorrect reasoning without explaining why it's wrong can actually confuse the model rather than helping it learn.
It seems like the explanations are really the key ingredient here.
Right.
If you think about it from our own perspective, if someone keeps showing us the wrong way to do something without explaining why it's wrong, it's going to be a lot harder to learn the right way.
Exactly. It highlights the crucial role of explanation in learning and reasoning for both humans and these advanced language models.
This is all really fascinating, but I have another question. We've been talking about these errors being crafted by humans.
Right.
But what if we could somehow let the LLMs generate their own incorrect reasoning paths?
That's a really interesting idea, and it's something that the researchers explored as well.
Okay.
They tested a variation where they used model-generated incorrect reasoning paths instead of the handcrafted ones.
Oh, so they were letting the model make its own mistakes and then analyze them.
Exactly.
That's pretty cool.
Yeah, the idea is that If the incorrect solutions are coming from the model itself, it might be even better at recognizing and avoiding those same mistakes in the future. Of course, they still had to provide the explanations for those errors manually.
Right, because the model can come up with the wrong answer,
Yes.
but it still needs help understanding why it's wrong.
Right.
Did this learn from your own mistakes approach actually work?
So the results were quite promising.
Okay.
They found that in most cases, using model-generated incorrect reasoning paths actually lead to even better performance compared to using the handcrafted ones.
Wow, that's really impressive.
Yeah.
It seems like there's something particularly effective about letting these models confront and analyze their own errors.
What's particularly interesting is that for DeepSeek 67B,
Okay.
the improvement jumped from 82.88% accuracy
Okay.
to 88.36%.
That's a huge jump.
Yeah, this approach seems to be unlocking a whole new level of learning for these models.
Yeah, it's really amazing. And it opens up some fascinating possibilities for the future if these models are so good at learning from their own mistakes. What does that mean for AI development as a whole?
Yeah, could we create systems that are constantly learning and adapting, becoming more accurate and sophisticated over time?
It's an exciting thought. Imagine LLMs that are constantly evolving and refining their reasoning abilities, almost like self-taught geniuses.
Yeah.
But before we get too carried away with the future, I want to come back to the practical applications of this research.
Oh, boy.
How can this new understanding of error-aware causes be used to improve the LLMs we use today?
That's a great question.
Hmm.
I think there's some really promising applications,
Yeah.
especially when we think about how LLMs are being used in real-world scenarios. But that's discussion for another time.
So we've really been digging into this research on chain of thought prompting
Yeah.
and how incorporating errors can actually make these LLMs better.
Right.
But I'm thinking about the bigger picture, like how can this understanding be applied to the real world?
Well, think about how LLMs are being used today. They're powering chatbots, they're writing code, translating languages, even helping with scientific discovery. And in many of these scenarios, accuracy and reliability are absolutely critical.
Yeah, exactly. Like if you're relying on an LLM to generate code for like a self-driving car, a single error in reasoning could be catastrophic.
Precisely. And this research suggests that by training these models with error-aware demonstrations, we can make them much more robust and less prone to making those critical mistakes. It's like building in a safety net, teaching them not just the right path, but also how to recognize and recover from wrong turns.
So instead of just blindly following a set of rules, they're learning to think more critically and adapt to unexpected situations.
Right. And this could have a huge impact on how we design and deploy these models in the future.
Hmm.
Imagine LLMs that are less susceptible to biases, less likely to be fooled by misleading information, and better able to explain their reasoning process.
It's almost like we're moving from artificial intelligence to artificial understanding.
That's a great way to put it. We're not just teaching these models to perform tasks. We're teaching them to think in a more human-like way. And that has profound implications for how we interact with and integrate these technologies into our lives.
This whole conversation has really got me thinking differently about how we approach learning, not just for LLMs, but for ourselves.
Oh, how so?
We often treat mistakes as something negative, something to be avoided at all costs. But this research suggests that mistakes can actually be incredibly valuable learning opportunities.
I completely agree. If we're too afraid to make mistakes, we might miss out on the chance to really understand why those mistakes happen and how to avoid them in the future.
So that famous quote from Thomas Edison, "I haven't failed. I've just found 10,000 ways that won't work."
Exactly. And that's the spirit I think we need to bring to AI development as well. We need to encourage these models to explore, to experiment, and yes, to make mistakes. Because it's through those mistakes that they'll ultimately learn to reason more effectively and achieve a deeper understanding of the world around them.
This deep dive has been really amazing. We've gone from understanding the basics of chain of thought prompting to exploring its nuances, its sensitivity to errors, and this incredible potential of error-aware training.
Yeah, we've seen how coherent chain of thought allows LLMs to self-correct and how incorporating errors into their training can make them more robust and accurate.
And we even touched on some of the philosophical implications of this research, raising questions about the future of AI development and the very nature of learning.
It's clear that this is just the beginning of a very exciting journey. There's still so much to learn about how these models work and how we can harness their power responsibly.
So for our listeners who want to delve deeper into this topic, we'll include links to the research paper and other resources in the show notes.
And we encourage you to continue this exploration on your own. Think about your own learning process. Do you benefit more from seeing perfect examples, or from understanding the reasons behind common mistakes.
Maybe we can all learn a thing or two from these LLMs and their ability to turn errors into insights. Thanks for joining us on this deep dive. Until next time, keep exploring, keep questioning, and keep learning. Eclectic